In the previous video, we looked at the adapter pattern. In this video, we'll be looking at the facade pattern. The facade pattern allows us to provide a unified interface to a set of operations in a more complex subsystem. When facade is properly implemented, it offers us a high-level interface that makes the subsystem easier to use. You can think of the facade pattern as a type of adapter pattern, but over a larger span of operations. Let's begin by opening our starter files for this video, which can be found on this video's resource page. This simple console application simulates a portion of an application that manages files. If we click on User Repository, we'll see a struct for a simple user object and a class named User Repository. This class has a function that manages some REST API calls and a switch statement at the bottom. So it's essentially a consolidation of REST logic. We can see that our manager function takes a user, an operation, and a completion handler. We can click on both the file and the article repositories to see that they are nearly identical. We've also got a file name control that contains two simple enums for our status messages and our operation types. If we open main.swift, we can see that we've created some simple objects, and we've made a few calls out to each of our repositories where we're passing in objects and selecting which operations to perform. If we run our application, we can see in our console window that everything runs smoothly. This same set of operations could be achieved in a much cleaner way. However, rather than calling each of our repositories manually, we could just call one class and let it determine where to send our file. Here's where the facade pattern comes in. Let's add a new file to our application and name it Connect Facade. We'll define a generic class named Connect. This Connect class will hold an instance of each of our repositories. Next, we'll define a class function named Handle, which will take our object of type T and our operation that we'd like to perform. I'll go ahead and paste in the logic that determines which class instance we have. All we are doing here is checking to see if our passed object is a user, a file, or an article. If we get a match, we pass our objects and operation type into the proper repository. Now, I should mention that this code is not ideal. For instance, it can only manage 3 types. We're also not dealing with any of the edge cases or the necessary error handling that would go along with operations like this. This example was simply designed to convey how the facade pattern works. Alright, now that we have our Connect class complete, let's update main.swift with some new calls that will perform exactly the same. I'll delete all of our user repository calls, and we'll simply call our Connect class, then Handle, and then we'll pass in our user and our operation. If we build and run our application, we see that we're able to perform the exact same tasks as before, but using our new Façade Pattern API, which is more readable, cleaner, and less lines of code. In this video, we saw how the facade pattern can result in an elegant API. In the next video, we'll discuss our first behavioral pattern, the chain of responsibility pattern.